Right, this is a lesson for higher geography candidates studying atmosphere. Of the 5 questions in atmosphere, this is one of the most common. It's called the Earth's energy balance. Essentially, in this question, what you're going to be asked to do is to describe and explain why there's different amounts of energy at different points on the Earth's surface. In the lesson previous to this one, we were asked why only 51% of the Sun's energy reaches the Earth. Now that we've established our understanding of why only 51% of the Sun's energy reaches the Earth, we now need to explain why that energy is distributed unevenly. In other words, we are being asked, why has the surface of the planet not got an even surface temperature? Why are there hot areas and why are there cold areas? When you are being asked this question, when you're answering it, you need to start off looking at this diagram. Now this diagram is essentially a graph, and there are 2 important pieces of information. One is the black line that shows long wave energy, and 2 is the blue line which shows short wave energy. Short wave energy is energy that comes from the Sun. Long wave energy is energy that the Earth radiates back into space. Now, in the middle section of the graph, you can see there is more shortwave energy, more of the energy from the Sun, than there is energy that is long wave. What this means is that the Sun's energy is greater than the Earth's ability to get energy back out into space. Here on the graph, you can see that the Earth has more energy going out into space than the Sun has energy arriving. What this means is that in these areas there is energy deficit, and in these areas there is energy surplus. Put very simply, in this area there's more energy coming in, and in this area there's more energy going out. Long wave energy is energy going out, short wave energy is energy going in. This is important because along the bottom of the graph you'll see it says 0 degrees. That is because this is meant to simulate the equator, and there's a North Pole and a South Pole at either end. And this graph shows you that the North Pole is cold, the equator is hot, and the South Pole is cold. It's actually quite a difficult graph to get to grips with and to understand, and they can make this question a lot more difficult by expecting you to look at that graph and understand what it is that you're being asked. So that's why I'm beginning with it. To understand this graph more simply, there's a simple thing you can do, and that's to take it and flip it on its side like this. This is exactly the same graph as that graph is. Now, in this study, or in this example, we have 0 degrees, the North Pole, the South Pole, but this time arranged in a pattern that's much more familiar to you. We have the area of energy deficit at the South Pole, with more long wave than short wave energy, more energy going out than coming in. And in the equator we've got more short wave than long wave, more energy coming in than going out. To explain why there are areas of deficit and surplus, that's what we're being asked to do when we're asked to talk about the Earth's energy balance. We're looking to explain why there are areas of deficit and surplus. To do so, we use a diagram. And the diagram will be one that hopefully is familiar to you. We have the South Pole and the North Pole. We have the curve of half of the planet. We have the equator at 0 degrees. In fact, you might see that this is identical to that. We then draw on the atmosphere. And all we're being asked to do from this point forward is to explain why there are areas of deficit and areas of surplus. Key to your revision and understanding of this section of the course is this term and this term. Deficit and surplus. Okay? So, why are there areas of deficit and surplus? Thankfully, this is quite easy to explain. The first reason is that rays of sunshine, if I draw a ray of sunshine, like that, rays of sunshine that strike different parts of the Earth's surface have different effects. This ray of sunshine, and if you don't believe me, try drawing the diagram for yourself, covers a smaller surface area than this identically wide ray of sunshine. What this means is due to the angle at which the sun's rays strike the Earth, the surface area covered is much greater, so the sunshine is weaker. So our first mark, number 1, is that the angle of the rays means the surface area is greater, so sun is less concentrated. Now, that clearly is not a perfect sentence. I've done it in note form, but hopefully you get the rough idea. The angle of the rays of the sun means that the surface area is greater here, and therefore the sun is less concentrated. I would put a 1 on the diagram at that location to match it to my sentence. 2. A bit like when you're playing snooker, there's ricochets, okay? And the sun's rays approach at this angle and then bounce off into space. Whereas these rays here arrive much more directly and therefore land directly and don't bounce off. So number 2 is due to angle of incidence. That's the key term. Some sunlight bounces into space. And that would of course get the label 2. Next, at point 3, another good thing about this diagram is it kind of shows you what the answers are by if you can draw the diagram accurately, the answers are there in front of you, is that the sun at this location, 3, has to pass through physically more atmosphere before striking the surface of the planet than the sun's rays here. This distance from here to here is shorter than this distance from here to here. Therefore, the sun has to pass through more atmosphere. The sun passes through more atmosphere, so is more likely to be lost due to reflection. In other words, there's more opportunities for the sunlight to hit a cloud or a particle of dust or gas or any reflective surface and get bounced back into space, because there's physically more atmosphere between the sun reaching our atmosphere and then reaching the surface of the planet. The next one is also up at the top of the diagram. This is an ice cap, point 4. Point 4 is that the ice cap has a albedo effect and reflects heat. Right, that's the main points in the north half of the world. At the moment, you might be thinking that's going quite rapidly and we just need to slow down a second. So let me simplify. The exam question could show you this diagram, or it could simply ask you to explain why there are areas of deficit and surplus. That is known as explaining the Earth's energy balance. You don't need to draw this diagram. That will never be an expectation. You only need to draw this diagram, which I'll revise again at the end of the video. Points 1, 2, 3 and 4 can all be located in the upper half of the diagram, relating to the different surface area covered by the sun's rays, relating to the angle of incidence at which the rays strike, causing some to be bounced off into space, relating to the sun passing through different depths of atmosphere, meaning that more is lost to scattering and reflection, and shiny surfaces like the ice cap. That of course means there's more to say down here. So we can draw a wee cloud, and that's point 5. And there is thicker clouds cover at the equator, so heat is trapped more efficiently. It's quite a simple point really. Tropical cloud cover tends to be much thicker and denser, so heat gets trapped more efficiently. Next, this zone here at the equator tends to have a lot of tropical rainforest, which is dark in colour. So at 6, dark rainforests absorb heat, storing it. That's another feature of the albedo effect. Okay. We're getting towards the end of this answer now, and we're at point 7. Point 7 really sits apart from the diagram. It's separate to this whole process, and it's very much to do with the Milankovitch cycle. So I'm going to write this one out for you. The Milankovitch cycle is when the world, the Earth, has a wobble to it. Now, what I mean by that is the Earth doesn't just orbit the Sun, but it also slightly wobbles as it does so. Sorry, just go off camera there for a second. So here's the world. As you may know, the world is on an angle, and it goes round the Sun. But it also, as it does so, has this kind of gyration to it. This means that every so often, as that gyration takes place, the shiny ice cap points more away from the Sun, and sometimes points more towards the Sun. This varies the amount of reflectivity that the Earth has, and therefore, of course, how much heat it loses. So the Milankovitch cycle causes wobbles in Earth's axis. So more or less of the ice caps are revealed. This happens roughly every 42,000 years. I've run out of space slightly, so I'll just take this label away. Also, the Milankovitch cycle means that as the world goes around the Sun, its orbit is not a perfect circle. Its orbit is in fact a stretched ellipse, and therefore the distance between the Sun and the Earth varies, and that causes the amount of solar energy received to vary. The orbit stretches every approximately 97,000 years, causing the energy received to vary. And that's it. That's 8 marks for the energy balance. Once again, you're being asked in this question to talk about areas of deficit and surplus, areas where it's colder and where it's warmer, where there's less energy or more energy. And you're being asked to explain why they have less or more energy. You're going to do that by using a diagram. Now the diagram looks complicated because I had done it previously, but right now, just to revise this, I'll show you the simple steps you need to draw it. You draw nice and clearly a D, which is half of the world. It helps if you note the South Pole and the North Pole, and the equator. After that, draw on the atmosphere itself. Notice this time I'm just using one colour as you would in the exam. This is a beam of sunlight, and this is an identical beam of sunlight, in other words identical widths, at 2 different locations. So, the angle of the rays when they strike means that the surface is greater, so it's less concentrated. That is at location 1. Because there's more surface area here than there is here. 2. The angle of incidence means sun bounces off. All we have to do is add an arrow showing some sunlight bouncing off. 3. The sun passes through more atmosphere. This distance is greater than this distance. Therefore, this is 0.3. 4. Ice caps have an albedo effect. Draw an ice cap on, number it number 4. 5. There's thicker clouds at the equator trapping heat in. Simply draw your cloud and label it 5. 6 was about the rainforests, which absorb heat. And 7 is the Milankovitch cycle, which you don't need to have a diagram for, and is worth 2 marks if you properly explain it. That is 8 out of 8 and an A. And definitely practice drawing this diagram. This is the only diagram that you need for the atmosphere unit. Okay.